Okay, let's get into energy part now. Now here the separation between two levels, that is EG and T2G level, is represented by del O, triangle O, or 10 dq. Alright, and here it is represented by del T, you can say, or this also can be represented as 10 dq. In either case we call it as 10 dq. But one thing you have got to be very clear of, that when we are talking in terms of separation of energy of octahedral and separation of energy of tetrahedral, the separation is more in case of del O than in del T. And what's the relationship? The relationship is del T is equal to 4 by 9 del O. Alright, let's now understand by how much energy is EG positive and by how much energy is T2G negative. Alright, now we called it as 10 dq. So we can split this up into plus 6 dq, and this would be minus 4 dq. Alright, similarly here also the same thing would be there. Here it would be, now since there are 3 d orbitals, so here it would be 4 dq plus 4 dq, and here it would be minus 6 dq. Now why did I say so? Suppose the configuration is D10. So I will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons filled in, right? So there are 4 electrons filling up in EG level. So 4 into 6 comes to 24 dq. Alright. Now also filled in T2G orbitals are 6 electrons. So 6 electrons means 6 into 4, 24. So this is plus 24, this is minus 24. Add the 2, comes to barycenter 0. So there is no gain of energy, no gain or no loss of energy as such if you observe the calculation. And why is it so? It's all owing to conservation of energy. So that's how it is being distributed into 6 dq for this, plus 6 dq for this, and minus 4 dq for T2G. Alright. Similarly, even if you observe there, it would be the same thing. So this is how we explain the conservation of energy being followed while energy split up. Alright. Before getting into CFSE, let's revisit the energy difference part, T2G and EG energy difference part. Now what we observe is the separation can be done either as delta O or 10 dq. If it is done as delta O, then barycenter to EG would be 0.6 delta O, and barycenter to T2G would be 0.4 delta O. And if it is taken in terms of dq, it would be 10 dq, and for this it would be plus 6 dq, and for this it would be minus 4 dq. So it would be plus 0.6 delta O minus 0.4 del O for this. And if it is dq, it would be plus 6 dq here and minus 4 dq here. Alright, so same thing goes there also for T2G and EG. Let's try and understand crystal field stabilization energy. Now for crystal field stabilization energy, it is very much essential for us to know the series. The series is about weak field and strong field ligands. Now the example that we have chosen is COF6 3- and COCN6 3-. F and C are the ligands. Now let's check out which is weak field ligand and which is strong field ligand. Now this is the series through which we check it out actually. Now it starts from here. So these are all the weak field ligands, and as we move around like this and come over here at this extremity, we have strong field ligands. So these are all strong field ligands and these are all weak field ligands. Now what it does, let's check out example one by one. So let's take in fluoride, cobalt fluoride. Fluoride belongs to relatively weak field ligand. So the resolution that we have chosen is octahedral resolution, where we know Eg goes up and T2G comes down as the ligands are approaching via X, Y and Z axes. Alright, there are 6 ligands approaching. That's why 6. Now in case of fluoride, what we observe is it is weak field, so the separation is less, whereas if we compare here, this is strong field, so the separation is vast. Alright, so that's the initial difference that we see. Now what happens for filling up electrons in case of cobalt? Cobalt 0 has the configuration of argon followed by 3d7 and 4s2. Cobalt 3 plus has configuration of argon again and 3d6 and 4s0, 3 electrons being stripped owing to obtain +3 oxidation state. Alright, so we are left with 3d6. So we are left with d6 electrons, 6 electrons and d orbitals which are to be filled in. Now let's see what's the difference in filling up the two cases. First, in case of weak field, that is fluoride case, 6 electrons we fill in first, second, third, fourth, fifth and sixth is paired. Alright, whereas here in this case we fill in 1, 2, 3. Since this energy delta O is too much, so pairing is preferred over unpairing, so it's paired. Alright, so it all gets paired. So here unpairing is preferred, here pairing is preferred only because del O is very high in comparison to pairing energy, so pairing is preferred. Fine. Alright, so this is how it happens. Now let's get into actual calculation. Now we have filled in 4 electrons in T2G level, and we know T2G level already we had seen above is minus 0.4 delta O per electron. Alright, so we have got 4, so we multiply that with 4 and we also have 2 electrons here, and for this we know it is 0.6 delta O per electron, so we multiply 0.6 into 2 electrons. Alright, so net result is minus 0.4 delta O. Alright, this comes to minus 1.6, this comes to plus 1.2, so the difference is this. So this is the CFSE. Alright, we are not done yet. We have got to consider pairing also, so we would see that later. Now for this, what we do is we have got here 6 of them into minus 0.4, that gives us minus 2.4 delta O. Now let's talk about pairing. Now when we started initially, we had 1, 2, 3, 4, 5 and 6 one here, so 6 electron, but this part was already paired. So if we see here one pair, we can just neglect that because already initially itself it had one paired, so we are not adding up any pairing energy there. And when we check out over here, it has got 1, 2, 3 pairing, whereas initially it had only one pairing, so one pairing we can exclude, and as it was initially there, and 2 pairing we can add, so that's why we had added plus 2 pairing energy. So this becomes a total CFSE for complex cobalt hexacyanide, whereas for cobalt hexafluoride it comes to this value. So this is how we calculate CFSE. Typically, pairing energy value comes to around 15000 centimeter inverse. Understand these videos, make your basics strong, and then put in your attempt for solving competitive exam papers. Alright, and then I'm sure it would help you all, provided you put in best of your effort in understanding these videos.